Hi guys, I hope you're good since the last video. I'm exploring AI and finding the way to have something to listen to while running or working to keep feeding our brains with knowledge. So sometimes you get it when being explained in different ways. That's why I have hired 2 characters from Google AI engines, and they will be watching my videos and talking about the knowledge that I have shared with you, but explained in another way, with one character being the one who needs to understand stuff, and the other the one explaining the concepts using analogies. Please like and subscribe, and I leave you with Mira and Brett.
Okay, so let's say you're like a total Python fan, right? You love how flexible it is, massive community, the whole 9 yards. But then you keep hearing whispers about this other language, Rust.
Yeah.
People are saying it's faster, safer, like the future of programming.
Right.
Super intriguing, but also maybe a bit intimidating.
I can see that.
Where do you even begin with all this?
Yeah, good question.
Well, that is exactly why we are diving deep today. We're going to unpack this YouTube tutorial and it's specifically made for Python folks who want to, test the waters with Rust.
Cool.
I think it's going to be great.
Yeah, it's kind of like imagine you're fluent in Spanish, right?
Okay, yeah.
And then you decide, hey, I want to learn Italian. You're going to see some familiar stuff.
Oh, yeah, for sure.
Like cognates, patterns, but there's going to be some grammar and expressions that are totally unique. It's all about translating your programming knowledge into this new, powerful way of speaking. You know what I mean?
I love that. And our tutorial, it starts us off pretty gently, thankfully, with installation.
Okay.
So all you got to do is paste one single command into your terminal.
Oh, wow.
It's a long one, though. curl-proto equals https TLSV 1.2 SSF https.rustup.rs pipeboosh.
Okay.
And bam, that's it. You're ready to rock.
Nice.
But this command, it installs something called cargo.
Right.
So what exactly is that?
Cargo is like it's like a Swiss Army knife for Rust developers. It's your build system, your package manager.
Okay.
It does project management all rolled into one. Like if you take Python's pip and a virtual environment and smash them together, that's Cargo.
Okay, that's pretty handy. So we've got Rust installed, Cargo's ready to go.
Yep.
Now let's see how the language itself actually measures up to good old Python.
All right.
The tutorial, it gives us this little cheat sheet comparing those basic data types like numbers and booleans. Seem pretty familiar.
Yeah.
But then it gets to strings and things start to get a little more interesting. Rust, it has these things called mutable and immutable strings.
Right.
What's the deal with that?
That, my friend, gets to the heart of what makes Rust so unique, so powerful.
Okay.
It's all about memory efficiency and safety. So, by telling the computer whether a string can be changed that's mutable, or if it can't be changed to mutable, Rust can optimize how that data is stored and managed.
Oh, okay.
It's like you're saying, hey, computer, this data is set in stone. You can optimize for reading it quickly.
Okay.
Or, hey, this data might change. You got to be ready to handle those modifications.
So it's like you have this really fine-grained control over how your data is living in memory.
Exactly.
That's definitely not something we think about a lot in Python.
No, not really.
And it sounds like this could lead to some serious performance gains.
For sure.
But, I mean, does that mean every time we want to use a string, we got to decide up front if it's going to change? Isn't that kind of tedious?
It might seem that way at first, but honestly, it encourages you to think about your data and how you're using it differently. It's like planning a road trip, right?
Right, yep.
Do you need a car with a big trunk for all your luggage? Or can you get away with something smaller, more fuel efficient?
Oh, okay, yeah.
The decisions you make early on, they can have a huge impact on your journey.
I like that.
Thanks.
So it's not about being picky. It's about being deliberate. It's about setting yourself up for success later on.
Exactly.
Speaking of setting ourselves up, let's get to that classic Hello World program.
Right, yeah.
So our tutorial uses Cargo to create this new project.
Yeah.
And what's really cool is it automatically makes this structured directory for us.
That's right. And this is great because it shows how Rust just encourages good habits from the beginning.
I like that.
Instead of having one file with all your code jumbled together,
Oh, yeah.
you get separate folders for your source code, your tests, config files. It's organized.
Okay, so no more messy Python projects.
Hopefully not.
I can see why this would be good for bigger projects.
Definitely.
Compiling our Hello World program seems pretty straightforward.
Yeah.
It's just a simple cargo run command.
Easy.
But, I am curious, how does this whole compiling thing actually differ from running a Python script?
Good question. That's a major difference between these two languages. Python, it's interpreted,
Okay.
meaning it runs your code line by line as it's reading it.
Mhm.
Rust, though, Rust is compiled.
Okay.
So it takes your code, translates it into instructions that the machine can understand, then runs that compiled version.
So it's like translating a whole book from one language to another before you can actually read it.
That's a great way to put it.
Is there, a reason for this extra step? Does it have any benefits?
Absolutely. Compiling your code, it lets Rust do all sorts of checks and optimizations up front.
Oh, okay.
It can catch potential errors before your program even starts, and it can generate optimized code that runs crazy fast.
Oh, wow.
Like imagine a team of super meticulous editors and proofreaders going over your book before it gets published.
So the Rust compiler, it's our friend,
It is.
not our foe, even if it catches a few typos.
It's there to help.
Speaking of typos, this tutorial mentions, a strange quirk about Rust syntax.
Oh, yeah.
Semicolons.
Okay.
Sometimes they're optional.
Interesting.
What's up with that?
The semicolon saga.
Ah.
Okay, so most of the time you do need semicolons to end statements in Rust, just like a lot of other languages.
Right.
But that last expression in a function block, it doesn't need one. It's a little weird, but it highlights something important about how Rust is designed. It wants to be concise and clear.
So it's not just being random, it's trying to find this balance between easy to write, easy to read.
Right.
But I can imagine this would trip up some Python developers who are used to a more, relaxed style.
Yeah, I could see that.
So is the compiler forgiving with these sorts of things?
The Rust compiler, it's known for being pretty strict, but that's good, actually. Think of it like a super-powered linter that's always looking out for you. Catches potential issues before they become big problems. It might feel a little picky sometimes, but in the end, it helps you write cleaner, stronger code.
So it's like having this very attentive code buddy who's always got your back.
Exactly.
I guess it's better to have the compiler catch those errors early than have them turn into bugs later.
Oh, yeah, for sure.
Okay, so now that we've got the basics down, let's dive into something a little more meaty.
All right, let's do it.
Functions.
Cool.
So the tutorial walks us through making this simple function to check if a number's even. The syntax looks similar to Python, but there's one key difference.
What's that?
You got to be really specific about the types of data your function uses and what it returns.
Oh, interesting.
You're basically telling the compiler, hey, this function's going to take an integer and it'll give you back a Boolean.
Okay.
True if it's even, false if it's not.
Makes sense.
So it's not just about the logic of what the function does. It's about being clear about the data involved.
Right.
Is this just a style thing, or is there a deeper reason?
It's a fundamental part of Rust's type system, and it's one of the reasons why Rust is so good at, catching errors and making sure your code is safe. By knowing exactly what types of data are being used, the compiler can do these hardcore checks at compile time.
Okay.
Prevents nasty bugs.
So it's like this built-in quality control system.
Pretty much.
To make sure everything's in order before you run anything. That's pretty impressive.
Yeah.
But I imagine that adds a little overhead to developing,
Sure.
Are you constantly thinking about types when you're writing Rust code?
It takes some getting used to, especially if you're coming from a dynamically typed language like Python.
Right.
But as you get more comfortable with it, you start to appreciate the benefits, It's like learning to play an instrument.
Oh.
At first, the fingering might feel awkward, but once you get it, you can play beautiful melodies.
So it's not just writing code. It's like composing it carefully.
That's a beautiful way to put it.
I like that. Okay, I'm excited to see what other musical metaphors Rust inspires. But before we go too far down that road, let's look at how Rust handles code organization.
All right.
The tutorial brings up this concept of modules, which seems kind of similar to what we do in Python.
It is, yeah. Modules in Rust, they're like containers for your code. They help you group related functions and data structures, everything together.
Okay, so instead of having this giant file with everything crammed in,
Right.
you can break it up into smaller, more focused modules.
Exactly.
That sounds like a good idea.
It is, especially as your project grows.
Oh, yeah, definitely. The tutorial mentions using the mod keyword to define a module and then use to bring in code from other modules. So is that how we bring in code from like external libraries too?
Exactly. The use keyword is how you access code from other modules, whether it's part of your project or external libraries.
Okay, so we can define our own modules, import code from elsewhere. It's all starting to make sense.
It is.
But there's one more thing about modules that I noticed.
Okay.
The tutorial says that by default, everything in Rust is private.
Right.
You need to use the pub keyword to make stuff accessible from outside a module.
Yes.
Why is that?
Yes. Rust's love for privacy.
Yeah.
It's another part of its focus on safety and control.
Okay.
By defaulting to private access, Rust makes you really think about which parts of your code should be exposed to the outside world. Like, imagine building a house with really secure doors and windows.
Oh, yeah.
You decide who gets to see what, making your code more robust, easier to maintain.
So it's not just organizing our code. It's about designing it with security and encapsulation in mind.
Precisely.
It's like Rust is gently nudging us towards best practices, even at the syntax level.
It is. That's one of the things I really love about Rust. Yeah. It's not just about getting things done. Right. It's about doing them well. Writing code that's not only functional, but safe, efficient, and maintainable.
It's about raising the bar for programming.
Exactly.
I love that. So we've gone from installation to hello world. We've looked at some of Rust's unique syntax. We've even talked about modules and data types.
We have.
I'd say we've built a pretty solid base.
For sure.
What stands out to you so far? Anything surprising or particularly interesting?
What strikes me is how Rust manages to be strict and expressive at the same time. It has all these rules and constraints, but it also gives you so much power and control. It's like a really well-designed game, clear rules, but tons of room for creativity and strategic thinking.
I like that analogy. And it makes me even more curious to see what else is waiting for us in our Rust adventure. But before we jump into the next part of our tutorial,
Okay.
I want to leave you with something to think about. If Rust is all about being explicit and having control, does that mean it's less flexible, less expressive than Python? Or could it be that these constraints actually help us unlock new levels of creativity and elegance in our code?
Ooh, interesting.
Think about that, and we'll pick up this thread in part 2 of our deep dive.
Can't wait. So, welcome back. I hope you've had some time to ponder that question about constraints and expressiveness in Rust.
Oh, yeah, definitely.
It's a really interesting side of the language.
It really makes you rethink some assumptions about programming.
Yeah, it does.
But before we go full-on philosophy here, let's get back to our tutorial. It's about to bring up a concept that seems like really core to Rust, ownership. And this is where things start to feel like really different from Python.
Right.
So can you give us like a quick rundown of what ownership is and why it's such a big deal in Rust?
Ownership, it's one of the things that really sets Rust apart. It's a game changer for memory safety and performance.
Okay, yeah, I've heard people talk about that.
It's basically how Rust manages memory without using garbage collection, which is what Python does.
Oh, okay, so no garbage collection in Rust. What does that actually mean, like in practice? How does ownership work?
Imagine you have a physical book,
Okay.
like a really special first edition. You own that book, you're responsible for it.
Right,
You can lend it to someone, but you still own it.
right.
They can borrow it for a while, but they got to give it back.
Okay, I think I see where you're going with this.
Yeah.
So is it like every piece of data in Rust is like a book, and there's always one like clear owner?
Exactly. Every single value in Rust has one owner at any given time. When that owner goes out of scope, like say a function finishes running, the value is dropped automatically, which frees up that memory.
That sounds really efficient. No garbage collector coming around later to clean up.
Right.
But doesn't that strict ownership rule make it hard to like share data between different parts of your code? What if multiple functions need to use the same value?
That's where borrowing comes in. Borrowing lets you give temporary access to a value without actually transferring ownership.
Oh, sorry.
Like lending that book to a friend. They can read it, but they got to give it back.
So it's like saying, hey, function, you can use this data for a bit, but I'm still in charge here.
Right.
But how do we actually show these borrowed values in Rust?
That's where references come into the picture.
Okay.
A reference, it's like a pointer. It points to where the value lives in memory. It lets you access that value without actually owning it.
Okay, so ownership sets up who's responsible for the data.
Right.
Borrowing lets us share data temporarily.
Yeah.
And references are how we actually represent those borrowed values. It's starting to click, I think.
Good. Yeah.
But this is all still a bit abstract, you know? Can you give us like a concrete example of how ownership, borrowing, and references work together?
Okay, sure. Let's stick with our book analogy. Imagine you have a function called readBook. This function, it takes a reference to a book as input.
So it's not taking ownership of the whole book, it's just borrowing a reference.
Exactly. Inside that readBook function, you can use that reference to see the book's title, author, all those details. But you can't actually change those details. You're just borrowing, remember?
You're just looking, not touching.
Right. Like you can read the book, but you can't write in it.
That's a smart way to prevent accidental changes.
It is.
But what if we do need to change the data? Does Rust have a way to let us do that safely?
Of course it does. If you need to modify a value, you need mutable access.
Mutable access.
Yep. You get that by borrowing a mutable reference.
A mutable reference. So it's like getting a special key to make changes.
Exactly. It's like a key that lets you write to the data.
Okay.
But here's the important part. Rust makes sure that only one mutable reference to a piece of data can exist at any time.
Oh, okay. So it's like having one pen that can write in the book. Only one person can use it at a time.
Perfect analogy. That's how Rust prevents data races, which are a common source of bugs in programs with multiple threads running.
So these borrowing rules keep things organized and safe.
They do. They guarantee your code will be memory safe and free from these really tricky errors.
Wow, that's really impressive. It's like Rust is taking care of all the hard parts of memory management for us, behind the scenes.
It is. That lets you focus on the logic of your code and be creative without getting bogged down in low-level details.
It's like having an assistant who handles all the paperwork so you can focus on the big picture.
Exactly.
Okay, I'm starting to get the power of Rust's ownership system, but I'm also wondering, does this strictness have a downside? Does it make writing Rust code more, rigid or clunky compared to Python?
It definitely takes a different way of thinking. It might feel strange at first, but the cool thing is once you get those core concepts, it becomes really intuitive. You start to appreciate the clarity and predictability it brings to your code.
So it's like learning a new dance. It's awkward at first, but once you master the steps, you can move with grace.
Beautifully put.
Okay, I'm ready to see these ownership ideas in real Rust code. The tutorial is going to show an example with strings now, which seem a bit more, nuanced in Rust than in Python.
You're right. In Python, strings are pretty simple.
Yeah.
Just sequences of characters. You don't really think about how they're stored in memory.
Right.
But Rust, it's a bit different because of this whole ownership system.
Okay, so how do strings actually work in Rust? What makes them different?
You have two main types, string and infretter.
Okay.
A string, it's allocated on the heap. It can grow. It owns the memory where the string's data is kept. And you can change its contents.
So like a dynamic notepad where you can add, erase, change text as you need.
Exactly. Now, an insetter, that's an immutable reference to a string slice.
A string slice, what's that?
Basically, it's a view into a part of a string.
Oh.
It doesn't own the data it points to, and you can't change it. Imagine a bookmark pointing to a specific page in a book. You can read the page, but you can't edit the text.
So entos is for when you need to read a string but not change it.
Yeah.
And string is for when you might need to modify it.
You got it. And that's where Rust's ownership and borrowing rules come back in.
Ah, okay.
If you need to own the data and possibly change it, use string.
Right.
If you just need to read a part of a string, use Instar. It's more efficient because you're not copying or allocating more memory.
It's like giving someone a photocopy of a page instead of lending them the whole book.
Precisely.
Much more efficient. Okay, so Rust gives you choices depending on how you need to use the string.
It does. The tutorial also shows how you can go between string and instar using methods like toString and astar.
So we can switch back and forth?
Yep. That lets you adapt your code to different situations and use memory efficiently. If you're giving a string to a function that only needs to read it, you can pass an astar and avoid extra copying.
That makes sense. Okay, I'm getting the hang of strings in Rust, but I have a feeling this is just the start of how ownership and borrowing affect different types of data.
You're right, these principles apply to all sorts of data structures in Rust, from arrays and vectors to structs and enums. It's all built on these ideas.
Wow. We've gone really deep into ownership, borrowing, references.
I have.
It's definitely different from how we think about memory in Python, but I'm starting to see how elegant and powerful Rust's way is.
It's pretty cool.
What stands out to you as we've been exploring these core ideas?
I think it's amazing how these low-level details actually make your code more expressive. By having these strict rules at the memory level, Rust lets you build complex systems without worrying about common problems, like dangling pointers, data races, all those nasty things.
Like Rust is saying, hey, I've got this memory stuff covered, you go make something awesome.
Exactly.
And speaking of making awesome things, what's next on our Rust journey?
Let's keep going and see what other surprises Rust has for us.
Okay, so we've covered ownership, borrowing, references, like the core of Rust. Right?
Yeah.
They take some getting used to, I'll admit.
Definitely.
But I'm starting to see how they all work together to create this like incredibly strong and efficient system.
It is.
But our tutorial's not done with us yet. It's time to talk about structs.
Okay.
Now, I have a feeling these aren't just your, average data structures.
You're right. Structs in Rust are more than just containers for data.
Okay.
They're like blueprints for building custom data types, ones that fit your program's needs perfectly.
So it's like we're not stuck with the basic building blocks anymore. We can make our own specialized Lego pieces.
Exactly. Imagine you're building a house.
Right.
Instead of just having generic bricks, you can make custom pieces for walls, windows, doors,
Right.
each with its own shape and purpose. That's what structs let you do in Rust.
Okay, I'm liking this analogy.
Yeah.
So our tutorial shows us how to define a struct called book with fields for title, author, year published. It even shows how to create like instances of this book struct and get to its fields.
Right.
Kind of similar to working with objects in Python.
Yeah, there are some similarities.
But what's really interesting is how Rust's ownership rules apply to structs too.
Ah.
When you make an instance of a struct, it owns the data in its fields.
Right. It's like building a house. You own the walls, the roof, the whole thing.
So if we pass a struct instance to a function, we're basically handing over ownership of the whole house.
Exactly. But what if you just want to let a function peek into a specific room,
Okay, yeah.
without giving up ownership of the entire place?
Right. That's where borrowing comes in again.
You got it.
So we can borrow individual fields of a struct using references, like any other piece of data in Rust.
Precisely. You can grant temporary access to a specific field without giving up ownership of the whole struct.
So it's like giving someone a key to the library, but not to the whole house.
Perfect analogy.
They can look at the books, but can't, knock down any walls or anything. Exactly.
Okay, this is starting to make a lot of sense.
Good.
Structs give us a way to create these custom data types with clearly defined fields. And then we can use Rust's ownership and borrowing rules to control how those structs are used and accessed.
Right. And this is just the beginning. You can define methods on structs, implement traits,
Okay.
which are kind of like interfaces in other languages.
Right.
You can even nest structs to represent more complex data.
Wow. So structs are like these versatile building blocks that we can use to create all sorts of sophisticated data structures.
Yes.
All while staying true to Rust's focus on safety and control.
Exactly. It shows how Rust's seemingly simple concepts can be combined to create a powerful and expressive system for data.
Okay, I'm ready to put my architect hat on and start designing some custom structs.
Awesome.
But before we go too crazy, our tutorial has one last topic. Enums.
Right.
Can you give us a preview of what those are all about?
Enums, or enumerations, let you define a type that can be one of a set of fixed values.
Okay.
It's like picking a flavor of ice cream. You have limited choices, and each choice means something specific.
So instead of working with any random data, we're dealing with predefined possibilities.
Yep. The tutorial uses a traffic light as an example. It can be red, yellow, or green.
Yeah.
Each color has a clear meaning for drivers.
And enums let us represent those states in a type-safe way, so our code can't accidentally set the traffic light to, blue or something.
Exactly. You can even associate data with each option in an enum.
Oh, interesting.
Like imagine an enum for HTTP status codes.
Okay.
Each variant represents a code and includes the numeric value and a text description.
So it's not just naming the possibilities, it's attaching more info to each option.
Right. Enums are a really powerful way to model categorical data.
Well, that brings us to the end of our Rust deep dive. We've gone from installation and hello world to ownership, borrowing, structs, enums. Wow, we covered a lot.
I feel like we've explored so much. What's your final takeaway for our listeners who might be thinking about trying out Rust?
Rust is a language that rewards curiosity and a willingness to learn. It might seem daunting at first.
Yeah, a little bit.
But its elegance and power become clearer the more you explore. You might even find that Rust's unique approach changes how you think about programming.
Totally agree. It's been a really eye-opening experience, and I feel like we've only just scratched the surface of what Rust can do.
There's always more to learn.
So, to everyone listening, don't be afraid to step outside your comfort zone and give Rust a shot. You might discover a whole new love for programming. Until next time, happy coding, everyone.
Thank you, Mira. Thank you, Brett, for presenting my video in this way. That was amazing. You used my words and video examples perfectly. I might ask to work with you again, as I'm very busy at the moment. Hope that you liked the video format, guys. Please like and subscribe, and see you next time.